generators and salient pole rotor synchronous machine. This is turbine which rotates the rotor by the action of hydro energy of water flow. The turbine shaft is same for rotor shaft. This is bearing bracket. It is fabricated from steel plates. It is used for supporting the bearing that controls the position of the rotating part of machine. It provides foundation for brakes and lifting jacks. This is stator frame supports the weight of the armature core. Upper bracket and bearing and exciter. Stator core is made up of cold-rolled grain-oriented silicon steel and carries armature windings. Stator winding is 120-degree displaced three-phase star-connected distributive winding for carrying induced current. It is insulated from tape impregnate varnish with mica paper and resins. Bearing is thrust and guide bearing below the rotor. It enables rotational movement of shaft. Reduce rotational friction. It supports loads. Rotor is made up of several components including field poles, rim, spider, damper winding, salient poles, field winding. These spokes are called spider arms made up of steel plates. It is attached to the shaft by hub. Bolts fitted into rimmed holes in spider arms. These are salient poles, that is projected poles if 10 to 100 poles depends upon requirement. They run at low speed from 150 revolutions per minute to 1000 revolutions per minute. Concentrated field winding provided on pole face and having damper winding on pole shoe to damp the oscillation due to uniform flux distribution. The electromagnetized rotor set up rotating magnetic field in uniform air gap between stator and rotator which cuts the stator conductor. Adjacent north-south pole pairs links with three-phase winding and induce alternative voltage. These are salient poles and these are concentrated winding. It forms different north-south pairs. The turbine blade and shaft connecting them to the generator are called the runner which rotates. Rotor. This is an exciter mounted on shaft which is in rotating silicon diode rectifier that supplies DC to field winding of rotor by the help of the AVR which controls the AC voltage output from stator. The magnets are lined up so that adjacent poles always have opposite fields to each other, north, south, north, south. These are rotor salient poles which gets electromagnetized from external DC and rotating magnetic field is set up as rotor is running by action of turbine. So this rotating magnetic field poles pair cuts the stator windings at three different phases and an EMF is induced in stator, hence current is drawn after circuit completes. Each time the pole makes one full revolution, one pulse of AC power is generated in the windings and transmitted towards the grid by conductors attached to the stator, because the stator is connected to the grid. It is important that the pulses are in time with the grid frequency. When the pulses are in time with the grid frequency, we say that the generator is synchronized. System conditions can push the stator's magnetic field out of sync with the rotor. The difference between the movement of the stator magnetic field and the rotor magnetic field is the torque angle. The rotor has many electromagnets on it, producing a consistent flow of power. The generator produces three-phase power by using different conductors to carry the power generated along different parts of the stator. As shown here, this creates a three-phase alternating current, which is represented by the sine wave.